Cloudflare just dropped their Cloudflare Mesh, and people have some takes. Some are saying Mesh VPNs are dead, others are wondering what this means for peer to peer networking in general. So instead of speculating, we set up a bunch of machines across AWS, Google Cloud, Hetzner, and some residential networks, and ran real benchmarks across NetBird, Tailscale, and Cloudflare Mesh. Same machines, same methodology, same conditions, and the results were honestly pretty interesting. But before we get into all of that, we need to back up a little and talk about peer to peer versus edge routing, because there are some fundamental architectural differences that will explain basically everything you're about to see. NetBird is a peer to peer network, and the way that this works is each device establishes a control channel with a central control plane. Now, that control plane does not carry actual traffic. What it does is facilitate the connection between your devices, handling things like the key exchange and signaling. Once that's negotiated, the devices establish a direct peer to peer connection between each other. So, simply put, we have a user's laptop here and we have an AWS server. And the NetBird control plane will have access to both of these, negotiate that connection, and then establish a direct bi directional connection between the two devices, of course, depending on your policies and how you have it set up. With policies, you can define who exactly is able to talk to who. But the important thing is once these connections are established, data will flow in between them and nobody in the middle sees it, touches it, or routes it. Now, Cloudflare Mesh is a little bit different. Each device connects to the closest Cloudflare point of presence, or POP. These POPs can be in completely different regions. From there, Cloudflare leverages their private backbone to connect all of these POPs over fast internal channels. They call it a mesh network because any connected device can technically reach any other connected device through this infrastructure. But every packet still travels through Cloudflare's network. So your traffic goes from your device to the nearest POP across their backbone to the POP closest to the destination. And this is important for two reasons. First, Cloudflare can technically decrypt and inspect your traffic at the edge since it's not peer to peer encrypted. They handle all the encryption. And second, every packet is taking a detour through their infrastructure, even if both devices are sitting in the exact same data center. Now, to give credit where credit's due, Cloudflare Mesh is a significant upgrade compared to what they had previously. Before, the only way to use this was user to infrastructure connections. Mesh now unlocks true bidirectional device to device connectivity, which is new for them and a big step forward. But the architecture still fundamentally routes everything through their edge, and there are some performance concerns that come with this. For testing, we used Ubuntu 24.04 with iPerf3 for throughput testing on both upload and download. Between all these machines, we cycled through NetBird, Tailscale, and Cloudflare Warp. We tested across AWS East and West, Google Cloud, multiple Hetzner data centers, regional offices, and even our CEO's home network. Big shout out to both Misha and Mycon for staying up so late to run these tests. Do note, network conditions do fluctuate, so it's really hard to get like perfectly scientific numbers, as we saw variations between runs, but the patterns were consistent. And of course, some of these residential ISPs are limited, so the overlay differences only really show up when the underlying connection has enough headroom. So probably most importantly, let's start with the European performance, because this is where things are real interesting. When we tested this in the same country between two different Hetzner data centers, all in Germany, the speeds were remarkably different. NetBird hit 1260 megabits on both upload and download. Tailscale was right there at 1300 and 1220, both of them blowing past a gigabit, while the Cloudflare Mesh had 250 upload and 290 download. That's roughly 5 times slower for two machines on the same provider in the same country. This means the traffic is leaving Hetzner, going out to Cloudflare Edge, and coming all the way back, and that detour is expensive. And then we decided to stretch this out further between two different European countries, still Hetzner to Hetzner, and this was a similar story. NetBird and Tailscale in the 750 to 840 range, while Cloudflare Mesh was in the 249 to 349 range. Peer-to-peer is about 2 to 3 times faster. We also went cross-provider, still in Europe, we went with Hetzner and Google Cloud just to make sure this wasn't like a Hetzner specific thing, and it was actually slightly better for peer to peer. With NetBird getting a slight edge on upload at 1410, Tailscale was doing great with download at 1390, and Cloudflare was sitting at 273 to 387. That's about 3 to 5 times faster for the peer to peer networks. And the pattern here is clear. For regional and local connections, especially in Europe, the edge routing model just can't compete with direct peer to peer. The traffic has to travel further and go through more infrastructure, and the numbers do reflect that. Now, it isn't all sunshine and rainbows for peer to peer. There are situations where the Cloudflare backbone is genuinely doing good work, and we do want to be fair about that. For example, from residential Japan to our Berlin office, Cloudflare pushed 158 megabits upload compared to NetBird at 81 and Tailscale at 24. On download, it was a bit tighter, but Cloudflare still led at 43 versus 28 for NetBird. But the real story is from Japan to a Hetzner data center in Germany, and this is where the backbone really shines. Cloudflare hit 224 upload and 269 download, and NetBird and Tailscale were sitting around 32 to 48 on these tests. That situation is 5 to 8 times faster for Cloudflare. So why? The direct path from a residential ISP in Japan to a data center in Germany is rough. There's really no great direct peering for a peer-to-peer connection to take advantage of. Cloudflare has a massive global backbone with highly optimized routes, and on routes like their edge network, it's doing exactly what it's designed to do. Not as dramatic, but we see similar things on cross-Atlantic routes, like our Berlin office to a AWS US East. Cloudflare's download came in at 287 compared to 186 for NetBird and 181 for Tailscale. The uploads were all pretty comparable though. And when we went from data center to data center, Hetzner Germany to AWS US East, the numbers got a lot tighter. Uploads were basically the same across all three, while Cloudflare still had better downloads at 215. NetBird and Tailscale weren't too far behind at 148 and 154. For US cross region, east to west, the peer-to-peer networks took it back as NetBird had a 358 upload, 423 download, Tailscale comparable at 347 and 339, Cloudflare at 162 and 300, where direct peering between cloud providers is strong. The peer-to-peer approach wins. On some residential connections, our Berlin office to Hetzner Germany, all three were comparable in uploads since our ISP uplink is bottlenecked around like 50 megabits or so. But download told a different story as NetBird hit 492, Tailscale at 466, and Cloudflare Mesh at 248. When your local bandwidth is the limit, you want the overlay adding as little overhead as possible. And I do have to clarify, I know some of you are wondering NetBird versus Tailscale specifically. Short answer is they're basically the same across every test. They kind of traded back and forth within normal network fluctuation. Neither of them really showed a consistent advantage over the other. Both are peer-to-peer networks building direct connections between devices. The differences are in the control plane, the management, and how you actually administer your network, not in the raw performance. So what does this mean? There's basically kind of three main points to summarize. If you're connecting infrastructure regionally, the peer-to-peer direct connection that you're going to get from a P2P network like NetBird is going to be your best bet. And I mean, we're talking like 2 to 5 times faster in some of the tests that we ran. The edge routing model just adds overhead that isn't necessary for a vast majority of use cases, especially in regional connections. If you're connecting devices across a long international route with poor direct peering, Cloudflare's backbone will genuinely help you. And as you saw, our tests in Japan proved that. Their global network provides optimized routing that just direct peer-to-peer connection simply cannot match on certain paths. And finally, the one that is probably the most important for me, and that is with privacy. With a peer-to-peer network like NetBird, your traffic is encrypted end-to-end between the actual peers. Data never passes through a third party in a decryptable form. With Cloudflare Mesh, all your traffic routes through their edge infrastructure, where technically it can be decrypted and inspected. That's not peer to peer encryption, that's a fundamental difference. And with NetBird specifically, you do have the option to self host the entire control plane, so you have the option to own the infrastructure top to bottom. Pretty nice touch if you're a privacy conscious individual. And to be fair, I will note both NetBird and Tailscale have a relaying functionality, so in situations where direct peer-to-peer isn't possible, but again, all that is encrypted with WireGuard. Being that NetBird's open source, you could go see for yourself how that traffic is handled with proprietary solutions like Cloudflare and even Tailscale, where kind of just taking their word for it that the data isn't going to be inspected or looked at. So is Cloudflare Mesh really a Mesh VPN killer? Well, it's a different approach with different trade-offs. For some use cases it's great, for others direct peer-to-peer is clearly the better option. So, with all that, if you're interested in seeing all the numbers and everything that we looked at, we have a full Knowledge Hub article with some nice graphs, some diagrams, all kinds of fun stuff. So go ahead and check out that link down below. And if you're interested in what we're doing here at NetBird, do subscribe to this YouTube channel so you don't miss our future videos. And with all that, do hope you have a absolutely beautiful day and goodbye.